Good day everyone. In today's lesson, we are going to discuss another circle theorem, and it states that if a line is tangent to a circle, the line is said to be perpendicular to the radius of the circle at the point of tangency. To understand what a tangent is, we need to draw a circle. Here is our circle. So what's a tangent? A tangent is a straight line that meets a curve or a circle at exactly one point. In this case, we are talking about a circle. Now, the blue line here is our tangent because it is meeting the circle at exactly one point, and we are going to label that point as A. This is A. This is a tangent. This is the point of tangency. We call this point of tangency. Let me digress a bit. What if the line touches the circle at exactly 2 points? What do we call that? Like in the case of the red line here, we call that a secant because it's intersecting the circle at point X here and at point Y here. We call this a secant. Alright, I can guess what's on your mind. You might begin to wonder, what about a chord? Yes, you're right. A chord also touches the circle at 2 points, but a chord is within the circle. And that's what makes it different from a secant. So we can say a secant is an extension of a chord. So this is a chord. We call this a chord. Now, let's go back to the theorem. The theorem once again states that if a line is tangent to a circle, that line is said to be perpendicular to the radius of the circle at that point of tangency. Here's our circle. Let's have our tangent again. Okay, we can take this to be a tangent, and considering the fact that our black line here is our tangent. Now let's draw a radius. We need to identify the center of the circle. Let's take this as the center of the circle. Good. Let's label the center of the circle as O. Then this is going to be our radius from the center to the tangent. So when the radius touches the tangent of a circle, when the radius intersects the tangent of a circle, then a right angle is formed. The radius of a circle is perpendicular to the tangent of the circle at the point of tangency. So we say this angle rather, is 90 degrees. And here we have it. This is 90 degrees. Okay, I'll call this 90 degrees. Here's also 90 degrees. And that confirms that sum of angles on a straight line is 180 degrees. So that's 90 degrees. Now we're going to use this theorem to solve some questions. Alright, this is going to be the first example that we are going to consider. For the sake of convenience, let's label this as A, this as B, this as C. We can call this place D. Okay, now it's really very obvious that OB is a radius and AC is a tangent. So therefore, angle OBC is 90 degrees because OB is perpendicular to AC. So we write this that OB is perpendicular to line AC. So therefore, angle OBC is equals to 90 degrees. Okay, now if you look at the diagram very well, you will agree with me that this is the whole of OBC. Okay, all right. If that's the whole of OBC, therefore angle OBD, that's our M here, our M, and 4M makes the whole of angle OBC. So M plus 4M, that's equals to 90 degrees. All right, yes, if you look at, we've said that angle OBC is equals to 90 degrees. So an M plus 4M is in OBC. All right, so this is 5M equals to 90 degrees, and divide both sides by 5. 90 divided by 5, so M is equals to 18 degrees. All right, in this example, we are going to start by labeling some points. So we label this as A, B, we call this C, and we call this D. Okay, one thing that is very obvious here is that OBD is an isosceles triangle, and that's because OB is a radius, OD is a radius. Both of them are radii, and since OBD is an isosceles triangle, therefore angle OBD is also P. So this angle is also P. That's because base angles of isosceles triangle are equal. So angle OBD is equals to P. And the reason is because base angles of isosceles triangles are equal. Okay, all right. If you look at OB is a radius, that's very obvious, and AC is a tangent meeting the circle at B. So since OB is perpendicular to line AC, so we say angle OBC is actually 90 degrees. So angle OBC, angle OBC is equals to 90 degrees. And that's because line OB is perpendicular. Line OB is perpendicular to line AC. Okay, all right, that's very good. Now you will agree with me that angle P, that's P degrees plus 69 degrees is equals to 90 degrees. Yes, that's very obvious. That's OBC is equals to OBD plus DBC. All right, so make P the subject of the formula here, and that's 90 minus 69, and that is going to give us 21 degrees. All right, this is going to be the last example for this lesson. So looking at this example now, you will agree with me that CB is a radius because we have been told that C is the center and CA is a radius. Okay, so that makes CAB an isosceles triangle. And the base angles of an isosceles triangle are equal. So what does that tell us? It tells us that angle ABC is the same as 3x minus 10. Okay, now CB is a radius and DE is a tangent. CB is perpendicular to DE. That's the theorem we're considering in this video. So angle CBE is 90 degrees. All right. Now let's look at a big triangle. That's a triangle ABE. Look at triangle ABE. Okay, so if you look at triangle ABE, you will agree with me that the sum of angles in our triangle is equals to 180 degrees. So let's take the first angle, that is EAB, and that is 3x minus 10. Okay, let's consider the angle ABE. The angle ABE is made up of 3x minus 10 and 90 degrees. So we're going to put the 2 there. That's what makes angle ABE. We have 3x minus 10 then plus 90 degrees. Okay, the third angle, and that is BEA, and that is 20. Okay, the sum of angles in a triangle, that's equals to 180 degrees. Alright, so let's collect our like terms. So we have 6x here, 6x minus 20, and we have plus 90 plus 20, that's 180. So plus 20 minus 20 goes out. So we have 6x, that's 180 minus 90. So 6x is going to give us 90, and x is 90 divided by 6, and that is 15 degrees. But we are not told to look for x. What we are told to find is angle BAC. And angle BAC is actually 3x minus 10. So we just substitute the value of x into 3x minus 10. Okay, so angle BAC, that's 3x minus 10. Okay, and what's our x value? Our x is 15. Alright, so 3 bracket 15 minus 10. And this is going to give us 45 minus 10. And our final answer is going to be 35 degrees. Thank you for watching.